Hi guys, welcome back to the channel. So we are doing this new thing here, pointing to two different areas. So we have did this typical problem, which is easy one. Let's try doing the second one. We have so many problems to solve in order for these to be completed. And moving to the next topic, probably binary search or some. So it's a medium level problem. Lead code 475 haters. And the problem statement goes like this. Winter is coming during the contest. Your first job is to design a standard heater with a fixed warm radius to warm all the house, okay? Every house can be warmed as long as the house is within the heater's warmth radius range. Given the position of houses and heaters on a horizontal line, retrieve the minimum radius standard of heaters so that those heaters could cover all houses. You need to follow your radius standard and the warm will be same. So let's see examples. So house is 1, 2 and 3, and the only header was placed in the position 2. If we use the radius 1, then all houses can be warmed. Okay, let's see what's gonna happen here. We have 1 and 4. The two heaters were placed at position 1 and 4. Okay, so notice that, okay, given positions of houses and heaters. So these are the positions of heaters and these are the positions of houses, and we have to uh, check for each heater so that it covers the maximum, the valid radius. And the length of houses and heaters will be between 1 and 3 into 10 to the power of 4. 1 10 to the power of 9. The value will be between 1 and 10 to the power of 9. So let's see. If we take one, the two heaters will be placed at position 1 and 4. We need to use a radius 1 standard, then all the houses can be warmed. So let's see how we can do this. Given the position of houses and written the minimum radius standard of heaters. Unity is the radius one standard. Then all the houses can be warmed. Where is this one? Here is one. Here is one. So it is covering here and here. And here it is kept at position 2, which is here. Let's see all the cases. Okay. Let's do one thing. Let's run to check what will be the output of this code. What is the expected output? So here the expected output is 3 because heater is placed at position 2 and we have houses 1 and 5. If we have to cover both 1 and 5, then we have to take the difference so the distance between 1 and 2 is 1. 2 and 5 is 3. So we have to take the maximum of the 2 to cover the complete distance here, because we only have one heater. Or if we have two heaters, then the answer could be 1 simply. If length of houses is same as length of heaters, let's add this test case. Right. This is going to be tricky, guys. Let's do a dry run so that we can understand. Let's take one here and one here too. 1 minus 1 will be 0. 2 minus 1 will be 1. Sorry, it is at 1, right? So 1 minus 1 will be 0. 2 minus 1 is 1. And let's sort haters. Let's sort them both first. So we have to return the maximum collision area. Let's add another test case for better understanding. Here we have one here. Three. 3 minus 1 here is 3 minus 1 is 2. Here if we take 1, so let's see how is the pattern going. So the difference here is 1 minus 1 0, and 3 will be here, 7 will be here, and 8 will be here, 10 will be here, 14 will be here, and 14 minus 21 will be 7. 14 minus 10 is 6. 3 minus 1 is 2. One can be shared with 1 and one can be shared with 3. 7 minus 3 is 4. 2 can be shared with 3. 2 can be shared with 7. 8 minus 7 is 1. Okay. Either it is shared by 7 or shared by 1. 8. 10 minus 8 is 2. One can be shared with 8 and one can be shared with 10. And 14 minus 10 is 6. So between 1 and 3, it can cover two values. And if the range is too big, this is the standard distance, and we can increase the distance based on we are covering the circle or not. So the first one can cover 1 and the second one can cover 1. So it's coming from back, right? So the first one can cover 2, second one can cover 2. The eighth one can cover, since 8 and 7 are side by side, uh, they can take their own positions and they cover 0 distances. But between 10 and 8, we can cover, 8 can cover one value and 10 can cover one value. Between 10 and 14, 10 can cover two values. Let's make a list out of it. We have only one filter. Here we got one. Here, if we keep 1 and 5, 1 can cover two values, 2 and 3, and 5 can cover two values, 4 and 3. 1 minus 5 is 4. 5 minus 1 is 4. 1 can cover 2 and 3, and 5 can cover 4, or 1 can cover 2, and 5 can cover 3 and 4. So, what can we do is, Here if you see the distances, we have one one can cover two, three can cover two also. So let's see how what can we do here. So here we take one, it can cover one value to its right, one value to its left. And when we are coming to 14, let's change one, let's do one thing, let's add another case here is, let's keep 18 here, let's keep 20, 18 here. If you have 18 and both 10 and 18 can share four elements in between, 10 can cover 11, 12 and 13, 18 can cover 17, 16, 15 and 14. But how is it? It should be 4, right? I guess we don't need to cover house number 14. So probably that is the reason why 15, 16, 17. So let's iterate over those houses. between 10 and 5. 10 minus 5 will be 5. 5 can cover 6 and 7. 10 can cover 8 and 9. Okay, sorry. So let's not waste so much time to trade, but I guess we are a step closer to the solution, but I don't know. Let's ask GPT. If we take 1 and 2 here, one can cover a radius of 1, and for 3, we have to take the maximum of 1 and 2. while houses of temp. Well, Oh, we tried our best. Let's ask GPT. How close is it? Oh, wait a minute. Let's see if there is no hints. Let's see what topic it belongs to. It's two pointers, binary search and sorting. Fine. Guide me to complete this and okay. For both houses and heaters, we compute just a half gaps between heaters like midpoints of influence range. This is clever but not quite what the problem asks. The heater radius is not really dictated by heater to heater distance, it's dictated by the closest heaters for each house. Okay, your main loop then tries to spread the coverage from each heater outwards across houses within a window. This is getting on because you are thinking in terms of global windows instead of just per house nearest distance. Where does this? The task doesn't require considering midpoints between heaters explicitly for each house. You just need the nearest heater distance. Okay. Once you have the distance for each house, the answer is just the maximum of those distances. Direction. Instead of list and spreading windows, reframing this way. For each house, find the distance to the nearest heater. For each house, find the distance to the okay nearest heater. Track the maximum among those. One second, guys. So, so let's continue. Instead of for each house, we have to find the distance to the nearest heater. Find, track the maximum among those. Okay. Now the real challenge. How do you efficiently find the nearest heater for each house? How do you find the nearest heater for each house? Okay. Like for every house, linearly check all heaters. Right. It's very slow. If both are sorted, you can use two pointers, walk through house and heaters together. Find closest heater position for each house. How close is your attempt? For somewhat closing spirit, you are already trained to leverage sorted heaters and expert heaters. Towards the 2.5, the simpler the code that is but slightly more involved. Both are valid solutions. Okay. Let's try to decode it ourselves. So if we keep a pointer on houses, we give one pointer here, one pointer here. Distance between 2 and 1 is 1. 2 and 2 is 0. 3 and 2 is 1. Well, it only have one heater. Let's take one. Distance between 1 and 2 is 1 and 1 is 0, so the heater is here itself. Then moving to the next one. 1 and 2 is 1. 3 and 2 is, 3 and 1 is 2. But 3 and 4 is more closer. Okay, how are we gonna do it? Okay, pointer 1 minus 1, 2 minus 1. So we have two pointers here. I'm gonna resume from where we have left. Welcome back to the channel, guys. We will be resuming where we have left. So, so we're trying to decode, complete this, right? Constants or elements will be between 1 and 10 to the power of 9. So let's see this properly again. You start both houses and headers. Instead of for each house, find the distance to the nearest heater. Track the maximum among those. Now the real challenge: how do we effectively find the nearest heater for each house? For every house, linearly check all heaters to slow optimized since both are sorted. You can use two pointers or binary search. Nearest element. If we have to do a search operation, nearest. So the nearest for 1 and 2 is this, for 3 and 4 is 4. But doing a search operation every loop, this is almost like a brute force, guys. Let's try to implement binary search. Let's pass an array and we have to find the nearest value in this one. The nearest value is for 1 it's 1 itself, for 2 for each house we want the distance to the closest. Let us assume through house, I through houses, hit a pointer J only moves forward, never backward because the houses are sorted. Compare its distance to hit at J and J plus 1. If closer, move J forward. Okay, got it, guys. We did the same, but if Initially j will be 0 and 0 plus 1 is 1. Right. Seems like it's working fine. And let's start submitting it, and if it is working fine, let's just press the intuition. Seems like it didn't work. Okay, we didn't expect this to have multiple, duplicate values. If we take 501, five hundred minus 1 is 499. 501 minus 1 is 500. 499 minus 1 is 488. And 499 minus 999 is 999 minus 499. 9 minus 4 is 500. We take 500. 500 minus 1 is 499, and 999 minus 500 is 499. But how is it true? 499 minus 1 is 498. Let's debug it. How is it going wrong? Initially we'll take 499 and 500. 499 minus 1 is 498. 999 minus 499 is 500. Sorry guys. Wait a minute. So the expected window here is 999. 98, 498. If we add, if we remove 499 minus 498, if we do 499 minus 498, then we'll get 1. If we do 999, 499 plus 498, we'll get 997. Okay, let's ask GPT how close it is. For each house. Of all these minimums. Where it's right now you only compare with the current heater, possibly move to J plus 1. That means you never check whether the current house is actually closer to current house is actually closer. We are checking it, right? We need to compute instead of just picking one, that guarantees each house is always compared to both neighbors. How do you rewrite your loop so that for each house you don't just move j once, but instead keep moving it? Well, j plus 1 is closer than j. Well, pair with the current heater j and possibly move to j plus. You never check whether the current house is actually closer to j minus 1. Wait a minute. We can take 499th one and 501th one, right? So 501 minus 999 is 498 and 499 minus 1 is 498. So we can take 499 and 501. Okay, okay, got it, guys. Well, guys, I understood now. So while we are moving forward, in this case, we can take two heaters. One is placed at 499 and one is placed at 501. And for 999, 501 is the closest one. For 499, one is the for one 499 is the closest one, and we're gonna ignore 500, which is not only close to the 501th position, but we didn't have such house. So let's try submitting it and discuss the intuition after this. Oh, yes, we have passed almost all the cases, and we can't even understand why you are getting error for this one. We are getting 0 as the maximum answer. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Very absolute. This is saying the code is perfectly fine, but why don't we see? But we should get the absolute value, right? Why aren't we getting the absolute value? Okay, 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 okay. So we are expected to have this, but we are getting a different value here. Why? If absolute difference. There is something going wrong here. Suppression is just we are facing the issue when we hit if. We have both the length same, so we have this minus this is 0. and 0 again. This will give 1. Okay. So if we find duplicates, then it's fine. If we have, let's comment this out and check if it is working fine. It is working fine. So the issue is simple, guys. We didn't expect. I didn't expect uh, haters list to have duplicates, but it does have duplicates. So in order for us to ignore the duplicates, we have to keep equal to. I'll explain the intuition after submitting it. Well, it is working fine. Let's discuss the intuition. What's happening here is we are going through each. So we kept a pointer here J in the heaters, and we are iterating over houses. So while moving iterating on the houses, we are checking if the different difference from the two adjacent values of the heaters, since all they are all sorted, we are checking the adjacent values, and if the j plus 1th element is less than jth element, we are incrementing it until we find j plus 1th element is greater than jth element. So when it is there, we are taking the maximum of answer and the absolute value. So why we have to kept equal to here is we might have duplicates in the houses list. Also we might have duplicates in the heaters list. uh, if the j plus 1th element and jth element are same, then the difference between uh, the absolute difference of j plus 1th element and absolute difference of jth element will be same. We won't be increasing it any further because both are same. We won't be increasing it. So in order for us to skip the duplicates, we kept equal to here, which escapes the duplicate, thereby uh, increment j plus 1th element until we find the least one at j plus 1th position. Least distance from the j plus 1th position. If the j plus 1th position is not least anymore, then we are stopping here and we are taking the valid distance and taking the maximum of the both. So I hope you guys might confuse for this is this said this said to take the minimum radius, but why are we taking maximum? uh, Answer is simple, guys. Since it is in the sorted order, for example, let me take an example here. This will be fine. So the 499 minus 1 is 498, and if we take 500, the distance is 499 from here and here too. So 500 will cover the entire part in 499th one. So what are we doing is, we initially did 1 minus 499, which the difference is 498, and we are going to implement, we are reducing 500 minus 999. Actually, for first, initially 999 minus 499 will be 500, but 500 minus 999 is way lesser, right? So we are moving it forward, and for the next element, 999 minus 501 is 498. It's even more less, right? So if we are taking a valid element which covers the distance uniformly, and if the valid element is greater than the current answer, which represents the radius, then we have to take the ultimate radius for the entire list. So that's it, guys. I hope you guys understood and like the video. If you like the video, upvote it so that others could find it useful, and let's see the other solutions as well. Let us let's compare what's happening from here. So j plus the house, j plus the house. We're incrementing j2 plus 1, and house minus the previous one. It's taking the minimum of the both. Okay, so he did the same, guys, but instead of adding this condition here, we are taking j and j plus 1th element, right? So he's taking j and j minus 1th element here. He's taking the minimum of the both and incrementing j based on this condition. If the heater is equals to the house, if the heater of j is less than house, well, gas house will be increasing as we move forward. If the element is equal to, it's no problem. If it increases greater than equal to, then we're going to increment j2 plus 1, and we are taking, right, guys? I understood it. So he is checking it until he finds same value. If it exceeds, if the house value exceeds the heater's value, then he is incrementing the j2 plus 1, and as long as the value is lesser, house value is greater than the heater value. For example, let's take an example here. Here the heater 499 is greater than 1, so it is taking 499 itself, and he is starting j from 1th element instead of 0. 500 is greater than 1, right? So we'll gonna ignore this all values, and 500 is less than 999. So we are incrementing 500 to plus 1. So we are taking a value which is less than the current value. So from the houses and heaters, if we are expecting to take j till, we are incrementing until j is no longer smaller than house, right? So we are taking the maximum possible jth element which is greater than the heater. If it is not, we are going to increment the heater here. So we took the 501 here, and the previous element. In this case, 501 is less than 999. If 501 is the greatest element, wait a minute, house 501 is less than 999, we have to increment it. Well, let's try to understand it later. Let's see other codes as well. Wait a minute. Did he did the okay? Did he did the sorting? There is uh, comments written here. Let's try to understand. Add two sentinel heaters so that a house can always be placed. Okay. So I understood, guys. The previous one too. So what's happening here is he added a negative infinity and positive infinity to the heaters list, and when it is sorted, the negative infinity will be moved to the front, and the positive infinity will be moved to the rightmost. So if the heaters reach its end, then there won't be any value that is greater than infinity. So it's gonna stop here. We are seeing this one, but the heaters list was edited such that we have negative heaters and positive heaters here. That's why j is kept to 1 instead of 0, because in the 0th position it is negative infinity. So I hope you guys understood, and I'm glad we have learned something new today. Uh, but I didn't feel completed with this because the idea itself is abstract in my mind. We'll forge the complete thing when we do it multiple times, and so I hope you guys keep learning. I hope you guys learn consistently and uh, able to find the patterns by yourselves. So thank you guys. Bye guys.